everybody. This is Todd. Todd, can you give us like just a brief introduction to who you are and what you do?
Yeah, sure. So my name is Todd Lingren, and I style myself as an NLP researcher. So I have a computational linguistics degree from UW, and through that, I got an internship at Cincinnati Children's Hospital. And I primarily work on healthcare research, improving healthcare through natural language processing and understanding of electronic medical records.
All right, so the data that you primarily work with then is related to medical fields and the text that lies within?
That's right, yeah. So we split the two types of data in the electronic medical record between structured and unstructured. So structured would be fields like diagnosis and name and birth date and stuff. And unstructured would be all the other text that the doctors and nurses type in. Usually that accounts for about 40% of the information in the medical record.
Okay, so that's kind of like their comments and stuff that they just dump in while they're in an appointment.
Yeah.
Okay, cool. So one of the things that we talk about a lot in our analytics courses are clustering and classification, and we ask our students to identify what's different between the two and what kind of distinguishes them from each other. And generally, I teach that clustering I like to think of it as more of a spatial exercise. It's calculating the distance between points and trying to find where the geometric mean is for each group. And frequently it's unsupervised, whereas like classification is often supervised and is aimed at identifying features within data that can help us put it into certain buckets. So we're taking existing features and then classifying them into a new feature. So a lot of my students tend to think that you can only do supervised with classification and unsupervised with clustering. So I'd be curious to hear from your experience how you use clustering and classification and on what types of data, and whether or not you do supervised clustering and unsupervised classification.
Yeah, so in general, you're right, clustering is unsupervised. That's the traditional way to look at it. There are some tasks that make unsupervised clustering kind of difficult. For example, if you look at functional genomics, if you're identifying which genes are causal for which diseases, it's not really a practical problem to look at it in an unsupervised clustering algorithm. It makes much more sense to be supervised, where you have in clustering such as k-means or the k-nearest neighbor algorithm, there are centroids that you can use to you could call that an exemplar for a cluster. In functional genomics, you might have a candidate list of genes, and those genes themselves have features, and they become the centroid of the cluster you're looking at or you're looking for. So you define those centroids by those gene features. And when you predefine those centroids and run the clustering algorithm on your data set, then each cluster is defined by how close they are to those centroids, depending on the clustering algorithm math.
Okay. Do you find that you sometimes use clustering in an unsupervised way to get an idea for like how many topics you might be looking at, or classifications, and then you supervise with either clustering or a classification algorithm to go from there? So like starting with completely raw data and you have no idea how many buckets you need to lump that data into, and just playing with it first and then doing something a little more structured?
Yeah, definitely. You usually have to, in clustering, you usually have to predefine the number of clusters to start off with, but you can do iterations on how many clusters. And if you get, for example, if you do choose 10 clusters and you look at the data and there are several clusters that have like one or two examples in them, and as opposed to dozens in the other ones, then it's probably unbalanced in terms of the number of clusters appropriate for the data set.
Sure, that makes sense.
So when we talk about classification, especially unsupervised, I would call that mostly just clustering. Even though it is classification, you know that there are some classes or labels, but you're not sure how many, and you're not sure what they look like from the composition of the data set. So the difference between unsupervised and supervised classification is really just that supervised classification requires labeled data or a training and testing and development sets. Unsupervised classification can be done in multiple passes, where the first pass doesn't have any labeled data. The second pass, you've maybe identified a couple of labels that you want to look at more deeply. But in general, to start with, you don't have any pre-labeled or training sets.
Okay. Do you do any, with your work with language, do you do any like topic modeling or sentiment analysis?
Yeah, latent Churchett algorithms
Okay.
are great for looking at that. I also like, in terms of clustering for NLPs, NLP tasks, you can look at Brown clustering for word sense disambiguation. So Brown clusters are words that basically are defined by their context, other words around them.
Okay.
In a biomedical context, we've done clustering of symptoms to help identify disease profiles. So, for example, diseases that might be missed in diagnosis, you can either do it in a supervised way where you know what symptoms a disease has, or you can do it in an unsupervised way where you're looking for groups of diseases that are common to multiple patients across the institution, and then you look at their data to see what they've been diagnosed with. Some of them might have been missed, some of them might have been correctly identified, and then you can move forward from there to develop a hypothesis.
Wow, that's so cool. So if you're looking at it in an unsupervised way at a bunch of symptoms, has that ever led to a realization that a certain disease presents itself a lot differently than literature would have otherwise suggested?
Yeah, actually, so we did this works really well with a project we did on autism. So we know that autism is typically not diagnosed properly, and using diagnosis codes especially, because a lot of times diagnosis codes are just used for referring a patient, whether or not they've already had been fully evaluated. So we ran an algorithm that defined autism using signs and symptoms, um, and and then when we did get a group of patients who we were confident that they had autism, we ran clustering algorithms to see what comorbidities each of those groups had. So it really presented itself as a evaluation of what autism spectrum looks like from a comorbidity standpoint. So some patients had some comorbidities that were clustered around cardiac issues. Some were more psychiatric, or some were epilepsy. And even there was a group of gastrointestinal. So it really shows the heterogeneous nature from a genetic standpoint of what autism looks like.
Wow. Does that help? Do you ever send what your findings and data off to researchers so they can go, like you mentioned, a gastrointestinal component? Does that ever inspire, or can it inspire researchers who are studying autism to break off or segment that group of patients where the correlation is between gastrointestinal symptoms and autism, and see if by treating the symptoms for their gastrointestinal symptoms that it helps ease some of the symptoms of their autism?
Along those lines, yes. I mean, that paper was actually published in PLOS ONE, and it was a group study with Children's Hospital of Philadelphia and Vanderbilt Children's Hospital, and using data from all three sites to get those clusters, using the power of of large numbers
Yeah.
to get those information. But you can do what you could do what you're talking about in terms of especially taking that slice of gastrointestinal comorbidities for autism patients, and then looking at the disease the genetic components and expressions of those to evaluate are there genes that are more susceptible to causing these symptoms. Yeah, we can evaluate those patients that have the certain comorbidities. For example, you can take the slice that has gastrointestinal comorbidities, and then you would run a genetic analysis, like a genome-wide association study, to look at the expressions for each one of those patients, and to see if there are genes that make them more or less susceptible to having those comorbidities that are common among autism patients in general. Or in that slice specifically.
Sure. Wow, that's so fascinating. So what got you into like data, what piqued your interest in data analytics in general?
So I've always been a data guy. I like looking at large mounds of data and trying to make sense of it. So whether that was looking at literature in language studies, or that was looking at learning a new language. And then I went back to school at 35 to get a master's in computational linguistics, because I wanted to be on the cutting edge of what was where linguistics was going, and really found a love for healthcare research in a way that just fulfills that that need to be significant and to have a purpose in impacting others' lives for the better.
Really awesome. Well, I know this will be so helpful for my students, and they'll really appreciate the connection between what they're studying and how people actually apply it in real life. I guess my last question for you then is, in general, we talk a lot about the challenges with data and using data, and some of the things that we study, especially when you start getting into like machine learning and AI and clustering, is needing a lot of data. So have you, what's your experience? I'm sure in the medical field, there's really no shortage of data, but do you have any other challenges, like cleaning the data? Since you're working with text, it can be pretty messy, right?
Yeah, it's frequently very messy. There are a whole host of cleaning procedures in terms of word sense disambiguation, which is really difficult in the medical context because they use abbreviations everywhere. And some abbreviations, I'll just let your students look up the abbreviation MS for the multitude of symptoms or synonyms that could mean. So cleaning the data is a big issue. In the medical realm, especially privacy. So we have a good access to data at our hospital, but anything that gets done in an identified way or identifiable way needs to go through an IRB, an institutional review board, for approval. So if we do it de-identified, great, we can just go to town on our hypotheses. But if we want to be able to identify those patients and help them later, or help other patients like them and know what those patients look like from a demographics point of view, then there are some regulation hurdles to get by.
Makes sense. Well, thank you for your time. This
Sure.
is really wonderful, and it's really great to hear about a specific field and how people use data and what they do with it. So
yeah, happy to help.